All right, welcome everyone to another live stream. This is the third or so in the last couple of weeks, so I'm glad that you're joining us. Really excited to have a return guest today, Jesko, who will be talking about and giving you a real natural, a real, I guess, example of his normal workflow using Binary Refinery. If you're not familiar with Binary Refinery, we'll go through real quick the installation steps and give you some ideas of what it is. But essentially, it's CyberChef for the command line. And if you're not familiar with CyberChef, well, it's a data transformation tool. It's a really important part of almost any reversing or malware analysis workflow to be transforming data from one state into the next, because a lot of obfuscation and other techniques rely upon that. Real quick, some channel administration. I'll be out of on PTO for the next couple of weeks. U.S. holiday, 4th of July, is also just around the corner. So there will be a little bit of a break here, but I'm going to return the first full week of July with the next stream, and that will be Kyle Cucci joining, and we'll be talking about reversing Go malware. So please mark your calendars, notifications, and all the social media stuff that I normally do to let you know that that's coming. We'll go out here in the next week or so, but just so that you're aware, the next stream's a little bit of a break here, and then streams will resume. Gosh, I'm forgetting the day, but I guess I have the power of a computer sitting right in front of me. So July 10th is when that's scheduled for. So still a little tentative, but I think that'll be a go. Okay, well, without further ado, I just got all kinds of. I just wanted to see. Yeah, hey Drew. Well, thanks for joining. Let's get Jesko on.
Hello.
All right, everyone.
I am
Okay,
on.
you're on. Yeah,
Nice.
you're on. I'm on. I'm hopefully not muted or anything. I've done that once or twice where I started the stream and forgot to unmute myself.
I can hear you well. I
Okay.
hope this. I mean, for those of you who don't know, I said this last time because it's kind of cool. Josh has this setup where we have I don't even know how to describe this. I'm not a I'm not a YouTube person or streamer, but he has a setup where I can see him, and then I can be in the back room, and I'm assuming that when I can hear you in this interface, then everybody else can hear you too.
Yeah, yeah. I think that's a safe assumption. Usually somebody says something. There's a handful of folks
Makes
that
sense.
join and like, we can't hear you. So, anyways, enough of that. Welcome back to the stream. So we did our last
Thank you.
stream, I think October, November of last year.
Yep. Oh man, time flies.
Yeah, I know, doesn't it? It's just amazing that even into this year we're already middle of June. So really looking forward to another session. Looks like you're going to be pulling apart some malware, a chain that was
Yeah.
analysis that I previously did. So if anyone wants to check that out, I'll go grab the playlist here in a moment and drop that into the chat.
Yep.
But just going to be a binary refinery only way of looking at, or largely looking at the
I hope
analysis.
so.
Yeah, so that's pretty cool. So how you been?
Yeah, pretty good. Very good, actually. Done some very cool stuff at work. It's you know how it is. I can't talk about some things, but it's been a good half a year.
Good.
I would
Yeah.
say, exciting things. And privately, I have a daughter who is now turning 2 this month, and
Oh.
that's also very exciting, of course.
Yeah.
So, all just going really well for me. So
Great. Yeah, that's great. My youngest is about 16 months now, so she's at that age where she's just becoming really interactive, and it's just a
Yep.
ball of fun. She might bust in here and say hi. Well, who knows?
That would be
So,
fantastic.
yeah, if she does, I'll make sure to let her say hi, because she's at that stage. Everything is a curiosity to her,
Of
and
course.
it's great to
And
see.
rightly so.
Yeah,
Very good.
yeah. Well, shall we get started?
Should I
You
go?
want to? Yeah.
Yeah.
Let's get your
So,
screen up and.
right. I'm sharing my screen. Can everybody see? Oh yeah, I can see what everybody sees. This is really awesome. Okay, so
Yeah, so
I was thinking.
same rules. If anyone in the audience here is having trouble seeing anything, let us know. I think the font size and everything looks really great from my perspective here. So,
And please do ask. I mean, that's obvious, but ask questions and interrupt me whenever. That's why it's live. So, right, Binary Refinery. I think I'm gonna move a browser over here very quickly. It's a thing that's on GitHub, and GitHub is the source for everything. Josh already said it. It is supposed to be the data transformation tool that is in the spirit of CyberChef, but what you do is you chain together a bunch. Let's see if I have a few examples down here. Like you chain together commands via like Unix command pipes on the command line, and then outcomes whatever you want to see. Um, the the GitHub README should have everything you need to know, and I will also just install. Like I will do everything from scratch. I'll just install it and then start using it, and I hope that this will be the best introduction to it. So Python 3, I think. Yeah. So this is, I'm on Windows, but this is WSL, so this is like a Linux environment. I'm going to create a virtual environment in the temp directory, and enter it. And then to install Binary Refinery, I recommend installing it into a Python virtual environment that you can turn on and off. And the reason for that is the number of commands that will be put into your path is enormous. I do try to not have the commands that get installed conflict with most existing commands, but but it's almost impossible to avoid conflicts on any platform, any OS, in any environment. So the ability to turn it on and off is kind of nice, I think. Right. And then to install it, it's just pip install binary dash refinery, and you can put if you install it by default, it will not pull in so many dependencies because there's quite a lot. And today, I think installing it with the in the extended mode will be enough. On the website, there's like a description of all of these. I can show you. So you can say, okay, please download all dependencies that Refinery uses, so I can use even the most obscure of commands like pcap parsing. I need all of it. And then the ones I would probably recommend is like either default or extended. It pulls in a moderate amount of dependencies, and yeah, it doesn't take too long. All right, and then you just do this, and it should just work. And now we're
It
going to
should
briefly
just
wait.
work. How many times have I said that in my career?
I mean, I have tests. I have like continuous integration, and I try to do the software engineering thing.
Yeah.
I'm not a software engineer, but I try to be good, and I try to do the right thing.
Yeah, I've been using it more and more in my normal workflow, and everything's been great. So
yeah,
it has just worked. I can confirm.
nice. Right. So this is not bad. Like the terrible red things you see here, you don't have to worry. I don't know why it does that, but I've done this before, and for some reason it complains. It's something it can't build. I don't know why. And if this doesn't work, I have a backup plan, obviously. Yeah, it takes longer than I expected because it seems to have to build something. And as you can see, like this is the extended one, and it already pulls in quite a few dependencies. I mean, you can see how you would want some of these, like LNK parse if you want to work on Windows shortcuts, PyPDF for parsing PDF files, and then cryptography for doing like crypto stuff, and like it's just there's so many commands in there. The first thing I always do to see if it worked is there we go. Now it breaks. Okay, it's gone. So the first thing I usually try to do to see if it works is just invoke the hex unit with its -h command, and the hex unit is it's the first program I think I put into this repository, and what it does is it does hex decoding and encoding. So that's all it does. There is a lot of commands in Refinery. I'll start with one I will use quite a bit, which is emit. Emit is a little bit like cat in that it can output the contents of a file, but it can also just output the contents. If I type refinery, it will just output the string. And if I now pipe this to hex -r for doing the reverse operation, it will hex encode this. And if we were to emit the string and pipe it to hex, it would decode the hex and output refinery. So this is the fundamental principle. You just chain, and now you can chain together multiple of these to do more than just this. And with this very brief introduction, I will go over here and look at this. So now we
And
want
just
to, yeah?
so everyone's clear, you are running this. This is Python, so it's portable, but you are in
Yeah.
Windows on a Windows host.
I am on Windows, and on Windows this is in a WSL prompt, so it is sort of a philosophical question whether I'm on Linux or Windows right now. It should work, like Refinery works on Linux, Windows, and Mac OS. It's written in Python and should be completely cross-platform. I'm a main Windows, so this is where I usually live. This is Farm Manager, and this would be the command line that I usually use. And I'm going here because I think being Windows native is sort of rare in the cybersecurity and reverse engineering community. So I'm trying to make this more digestible by using a bash prompt. But I'm not actually native here. I'm more native in this weird thing that you may have never seen before. So,
Okay, got it.
But yeah, it's written in Python and it's cross-platform. So I thought it would be nice to do something that Josh has done in one of his video series before, because I was planning to do a Refinery version of it anyway. And it turned out to be a little bit too lengthy and too complicated to put it into a tweet or an X post now, I suppose. So I thought, why not do it here? So this one is something we don't like. The exe is something that will be downloaded later. Initially, all we get on our imagine, if you will, you're a malware analyst and you're handed this doc file, and you want to know what is going on. What malware is delivered? What IOCs can you extract? The typical questions. So emit can also emit the contents of a file. And another unit that I will use all the time is peek. It's also one of the first units I wrote. It just gives you this very brief peek at the data. So it tells you size, entropy, and then it gives you the output of libmagic. So it says this is rich text for an unknown character set. Since we can do this. So this will decode it, and we can do this twice, so that it wraps lines, and we get a bit of an impression of what is in here. This already looks like a maldoc, right? There's nothing in this RTF except for this encoded object. Refinery has various units for extracting things from other things. Well, that is, I don't know how to put it in a better way. The point I'm trying, but this is leading somewhere. There is also one command in Refinery which is called xt, and xt is like an umbrella command for all of these extractors. So there is a command called xtrdf, which you can run on this input, and it will extract one carved binary blob from the RTF. But you can also use xt, and I would recommend that you try to use xt on a bunch of things, because it should be able to just pick the correct extractor for the format that is being input and pull out what is in there. So all of these extraction utilities, they follow the same sort of like command line API, where when you specify the flag -l, it will give you a listing of all the things that it can extract. And then you can specify Unix style file name patterns to filter this down if you want to actually extract it. And so if you want to actually extract it, you don't specify the -l flag. And if I do this, there's only one item. This will come out, and it's this. So this is a composite document file. So some sort of only embedded thing. And again, I will try to see if I can extract something from it, and I can. There's a binary blob in there. Again, I don't have to specify anything. We can just pull out the thing that is in there. And that is the thing. This is now data, so this doesn't look like it is a or it's not having the structure of anything that Refinery knows. Since this is an RTF document, and RTF documents are always equation editor exploits. Okay, they're not, but very often they are, and or very often they're exploit documents. I would be strongly inclined to suspect that this is shellcode, which is further there's further evidence right here with the E8 and then a small integer encoded in little endian, which looks like a call instruction to a near offset where quite likely the current the return address is being popped into a register, so the shellcode knows where it is. This is a very typical technique. And to get and everything before this is part of the, or I assume, actually I didn't actually check, but everything before this I assume is part of the equation editor object that triggers the exploit. So, and I don't know how it does that or why. I just think the shellcode starts here, and I'm going to pull it out. And what better way to pull out stuff from other stuff than regular expressions? The Binary Refinery unit for doing regular because I can't use grep. I wrote my own tool, which is called REX. It's also one letter shorter than grep, which makes it better. And REX you just give it a regular expression and it pulls it out. So we're going to get. Did I vanish?
No, that was just me playing around. Sorry.
So XE8 something, then 3 zeros, and then more. So that should be just that didn't work because we're on Linux, and I can't, on Windows this would work, but on Linux I have to do this, right? Yes. See, I am not native to this shell. Okay, and this I think is shellcode. We can try to disassemble it, and it looks pretty convincing. So ASM is the unit for doing disassembly. It probably does decrypt itself, and this disassembly unit, it's not great. It's not a good disassembler. It just allows you to do quick and dirty disassemble a few bytes, just a sanity check for does this even make sense. Now we could dump this to disk and load it into a binary analysis tool like Ghidra or IDA or Binja, but it's pretty short. I think it's not a lot of code, and with short shellcode like this, we can just try to emulate it. Just run it through an emulator and see if interesting strings or interesting stuff, interesting behavior pops out. In Refinery, there is a unit called vstack because it was I originally built it to get stack strings out of executables. But what it really does is it emulates code and remembers what is being written to memory. So that's essentially it. And of course, you can just use this on shellcode. I recently made an addition to vstack, so this is pretty new. This is in recent versions, where you can pick one of 3 different emulator engines. So the emulator engine that is used by default is Unicorn. There's also support, but there isn't quite support for Icicle, which is a new thing that looks very promising, but the support isn't great. And there's also support for third option, which is Speakeasy. And Speakeasy happens to work pretty well on the sample. I know this, and we're going to use it. So by default, I would just try to use it on and nothing happens. This is probably I would then probably turn on debugging. So for any refinery unit, you can specify -v or -vv for being verbose, and just trying to see what it does. For the VStack unit, this will show you like all the instructions it's emulating, and it will also tell you how long it has waited for an instruction to actually write something to memory. And it has a default timeout for this wait of 20, and this looks like the timeout was hit. So I'm suspecting we have to turn up the wait a bit. And if we do that, it does a lot more. Okay, looks good. So let us peek like 30 lines. And this looks really suspiciously like a downloader. URL download to file. And with a very recent release of Refinery, I can even do you one better. And with -A, you can turn on API call logging provided by Speakeasy. Or so I thought. Doesn't work. Why not? Very disappointing. It did recognize the A, right? Okay, I can't show you this cool trick, unfortunately. It's supposed to, well, I could show you in the other tab. Let's do it in the other tab. So, what did we do? We did xt, and then like rex, xe. I'm going to show you how it's supposed to look if only my release was already ready. So -A, Speakeasy, and wait for like 20. So I do not know why it doesn't work. I am unsure. So it's supposed to show you the API calls, and I can show you what Speakeasy does because we have Speakeasy. So this is x86. Yeah, okay. This is what I said when I said I'm going to do it live. Mm-hmm. So sometimes, and I never do this in Refinery demos, but you have to do it in real life all the time. Sometimes you have to dump a stage to disk. And for some reason, I almost never demo the dump unit, which is the command that can dump a file to disk. So we're going to dump this shellcode to disk. And then we can use Speakeasy, which is not part of Refinery. It's a different tool, but it's both a tool and can be used as a library. Refinery uses it as a library, which it's an emulator. And if we use it in raw mode and we specify x86 architecture and we tell it that this is the target, I'm pretty sure, yeah, that it will tell you that this calls URL download to file on this URL. So VStack with the -A option was supposed to show you this, but apparently it doesn't. I don't know why. But it doesn't matter so much because we already thought it was a downloader. We know that there's a URL somewhere in the emulated memory. And now comes the third unit that I use all the time, probably one of the most important ones. It's XTP for extract pattern. And it is supposed to just do the thing, just pull out the indicators that you're interested in. Like it's basically my personal regular expression library. It has regular expressions for URLs, domains, IP addresses, the usual things that you care about as a malware analyst. And it just tries its hardest to pull these things out of a binary blob. That's about it. Okay, and there you go. That is the first stage. This is how you would get to this URL, and we even saw how to verify that it does actually download this. Gonna take a sip real quick.
Yeah, awesome. Question from Drew, and welcome, Karsten.
Oh yeah,
Malware analysis for hedgehogs just joined on YouTube.
Hello, Karsten.
Yes, hello. Drew was asking, and I was thinking it too, because I find that watching you, and this is I think normal for any like someone who's really familiar with a tool or a process, is it just everything looks so natural and easy, and you're like, oh, that's all you got to do is that command, and then you
Oh,
go
yeah.
back to redo it, and it's like, okay, I can't remember anything. And so, is there like a
Yeah.
cheat sheet, or I know you have tutorials
Yes.
on the GitHub?
Yes. What I didn't originally realize how good this, or I mean, okay, I'm not trying to. I think the best thing to do is use binref. This is a command that gets installed by Binary Refinery, and it is the only command that is not not a unit, not something that wants to read from STD, and it's just a normal command line utility,
Mhm.
and you can, I don't know, this will not work. Of course not. But emulate, for example, should work. So you can do binref emulate, and then it will search. It just does a plain text search on all the units there are. I should really put the word shellcode somewhere in vstack. Anyway, and for vstack it says the unit emulates instructions at the given address. And this would be a way to find vstack. You could also type binref RTF, for instance, if you have an RTF document, and then you see that there's carve RTF, which can be used to carve things from RTF documents. There is RTFC, which implements the RTF compression format, if you've never heard of it. And of course, there's like XTRTF, which is the one we used, extract embedded objects in RTF documents. But I think this is the best way to find the thing, like to find a unit that does something you want. Um, Alternatively, of course, there is documentation, and it is not totally horrible. You reach it through this button. It's on binref.github.io. And the front page of the documentation is just a list of essentially all the units with their help text. And the help text is essentially the documentation. So in here, you could also just search for RTF, and you would find all these. But of course, it's very verbose, right? You also find the code, and yeah. I think the binref utility on the command line is probably the most reliable way to
Okay.
find units, I'd say.
Very cool. Okay.
Did I more questions?
No, I think that was it,
Okay,
at least
okay.
for the time being. So yes, if you have questions, don't hesitate to use the chat. Let us know.
So let's see. This is where we were. So we took the document. We pulled out this Oli container. We pulled out a native, like a blob, a binary blob that implements the equation thing. Then we carved out we regular expressioned out the shellcode. We emulated it, and from the emulated memory dump, we pulled out the download URL. And now, what you would have to do as a malware analyst is procure whatever is or was at this URL, and there's a few ways to do that, depending on what you have available, VT URLs or whatever. In my case, I'm not going to do that now. I already have the executable. So this is the one that supposedly was at this URL. Oh my God! I just saw in the chat. Is there a binref MCP planned? I tried. I will cite I will quickly address this. I tried. It's hard because there are so many refinery units. The context windows are not so big. I mean, they're working on it. Context windows are not so big, and like telling the AI all the units and what they can do is too much for many of the context windows. So it's the extremely modular nature of binref actually makes it difficult to build an MCP server around it. The next, if I had time and I was like, Yeah, if I had time, let's put it like that, I would probably think about making a selection of units and then exposing just a selection of units to the to the AI. But I haven't done the work, and I
Sure.
think anybody can, like, PR's welcome. Anybody can do anybody can do this. It's just a matter of writing the MCP server, but yeah.
Yeah.
So I wouldn't say
Awesome.
planned. I would find it I would be very interested to see if it can work, but with the most naive approach, I ran into a brick wall. So there you go. That's what I've done in this area. Back to the executable. Okay.
Yes. And that
So
was this was one of those documents. I was kind of curious at the time what were RTFs being used for yet, and as you already discussed, they're still using that old equation editor exploit from like 2017. I think there might be a couple of them, but they're still an active distribution, so somebody's finding success with them still. And I grabbed it from the Malware Bazaar, obfuscated, and that's the executable that came back to me. So
I think indirectly it tells you something about how bad people are at updating, because
I think it does too.
if if this still works, there have to be a lot of endpoints that have ancient, unpatched. I don't know what it like. Is it? I think is it exploiting Word? I think it is exploiting, or WinWord. I'm not sure
Yeah.
which one it is actually exploiting, but it must be ancient if it still works.
Yeah, yeah. In fact, I tried to go find an old enough version of Office that the exploit would actually work, and that I went down this rabbit hole. Did not. I was not able to find an old version, and I have some old versions of Office lying around in my NASs, and so yeah, I think it does indirectly tell you something about and I don't think it's just like sometimes you get the cruff, like the WannaCry stuff and other things that are just like now that they're out there on the internet, and they're constantly getting found and uploaded.
Yeah, the zombieware, right? The things
Yeah,
that are
yeah,
they're not actually infecting people, but they're just being uploaded in them. Sandboxes re-uploading things that, like, it's a
yeah,
perpetual. Yeah,
yeah,
I know what you mean.
yeah. I don't think this is the case with a lot of these. I think what's
Yeah,
showing up on places like the Malware Bazaar and AbusCH, or somebody is finding some level of success, whoever they're going after. And I didn't get into that, but anyways, long story. But that's the binary. So
I
it
want to
is.
get in one anecdote because I like to. I whenever people like this is unrelated to Binary Refinery, but it's a nice anecdote, I think. So people often, not often, sometimes they get asked about PDF files.
Mhm.
And my response is always, there are no PDF exploit documents. And I will continue to claim that there are no PDF exploit documents today until someone proves me differently. But when I started as a malware analyst, I did not know that there are no PDF exploit documents. And whenever whenever somebody asked me to analyze a PDF document, like, this is hard, right? You run it, nothing happens.
Mhm.
Okay, is this because you don't have the right PDF version? And I went on a rampage and scoured the internet and the web archive for all the Adobe installers back to the Stone Age. And I used to have a huge archive, and then
Yeah.
I built automation around installing each of them and opening the PDF with each of these
Oh wow.
versions.
Okay.
Like, I put in all this work, and never in 7 years of being a malware analyst have I ever seen a PDF exploit document. They're extinct. It's
I
just, I mean,
yeah.
in active use. I know historic samples. I know samples that
Yep.
I know, but I mean, actually being used today, I have never seen one.
Yeah, yeah, I agree. I think when I started looking at malware for real, that is, somebody was paying me to do that. The exploit kits were the thing, and when I learned kind of before that, PDFs and PDF exploits,
Yeah.
yeah, they're definitely out there. I've never come across one. I more recently went on a similar rampage, just like what are PDFs used for, and I went to places like Malware Bazaar, downloaded a bunch of them, and guess what? It's all phishing.
It's
So
all phishing.
it's all phishing.
There's some interesting stuff going on with PDF files. It's just not binary delivery. Like, it's not
Yeah.
exploiting anything. It's
Yep.
but I've seen some. Okay, we're getting off track.
Yep,
But
yep, sorry.
I
Yeah.
will continue analyzing this executable.
Hi, heaps overflow.
Hello.
Okay. All right. Awesome. I will give you more screen and
more screen is good.
more screen. Yeah. All right. Good luck.
Okay. Unsurprisingly, this is an executable. What I would always do is dump strings. How do you do this on Linux? Do you like? So we can do it with Refinery. To dump strings with Refinery, we use carve. So carve is a unit that can carve various forms of buffers from the input being an arbitrary binary blob. And the formats that it knows are integer, so just anything that looks like an integer, floats, any number, which is one of the two, strings, which in this case means a string literal, like something in quotation marks, multi-line strings, if you have multi-line strings, strings that can be parsed by the command line. I will skip a bit of it, and printable is one of the formats. So we can carve any. So little n is minimum. Meshes must have length at least n. So n8 printable. This should be like running strings. There's a lot. I will dump this to strings, and then I will try to do a Linux thing here, and I will. Okay. Strings is your very best friend. Okay, so this is all like some Windows APIs. It doesn't tell me anything. This, however, looks much more interesting. On AutoIT start register. I mean, if you're better than me, you have a library of YAR rules which will just tell you that this is an AutoIT executable. But this is pretty damning evidence. Okay. So how do you quit Vim? Like this. So it looks like this is an AutoIT executable. Okay. That is fortunate because there is a unit for that, which is called A3X. Again, you could do binref. Oh, not like this. Not like this. AutoIT. And you would find A3X, which says extracts embedded resources from compiled AutoIT scripts and decompiles the embedded script bytecode. The unit also works for on compiled AutoIT executables. So we would run A3X, and it has the same pattern extraction syntax, or the same like path extraction syntax as the XT unit. And it shows us that there are 3 files in this AutoIT executable. One is the script, one is called lards, and one is called backtrace. We can extract all of them and have a look at all of them using a frame. I've not brought up frames so far, so this is the first time. Many refinery units can produce more than one output. So for example, carve can carve out more than one buffer if there's more than one of the specified type. And these extraction units like A3X or the XT unit, it wasn't the case so far, but of course they can extract more than one thing. And if a refinery unit outputs more than one thing, you always have the option to specify as the last command line argument an opening square bracket. So right, this opening square bracket, I make it look like it is part of the shell syntax, but it's just an argument. It's just an argument to refinery, or to this refinery unit. And what it really means is, please serialize your output in such a way that the following refinery units can extract the individual chunks, the individual outputs from it. So, long story short, if you do it like this, you can we can peek each of the 3 extracted files. Like we can make peek operate on each of the outputs individually. Dash L0 means no lines, so just metadata. And we can see that this AutoIT executable contains 3 files. One is the script, and it was supposedly written on, this can't be right. I don't know where this is from. Oh, it's probably my, this can't be 2025. Interesting. I have to check where this metadata comes from, because no way this is from January, or is it?
So you're saying that that's when it
Oh,
was
no.
written in the AutoIT executable?
Yeah. Oh, is it that recent? I thought
It
I
could have
thought
been,
the sample.
yeah.
I thought the sample was older, but maybe it is.
Let me look. I don't recall all the details, but
No,
let's
this
see.
we just talked like time flies, and it was like 2025 has just started. This
Yeah.
must be
Well,
wrong.
I published these videos in the original analysis in
Yeah.
February of this year,
Yeah.
so I likely grabbed this shortly before that. So yeah,
No, I
it
mean,
probably
and
is.
then this is additional evidence to support the assessment that this is actively being used. Like this is
Mhm.
not zombieware. Like I was skeptical because I thought this was too recent, but it's not. Anyway, okay.
Yeah. Well, I am curious.
Metadata.
I don't, I skip as much about AutoIT as I can, but I'm really curious about some of this. How easy is it to, where is this data coming, this metadata coming from, and how easy is it to modify or mess with, and who would?
Yeah.
So
I
that's
think
cool.
it's so for adversaries using AutoIT, this is probably not. I mean, now I get into the whole talking about what adversaries do and don't. I mean,
Hmm.
of course, they could do all kinds of things, but the kinds of adversaries who I see using AutoIT, I don't think they have the technical proficiency to alter these timestamps. So they are extracted from the AutoIT. It's parsed out. It could be modified, of course. It's just a sequence of bytes somewhere. You could
Yeah.
put different data there, but as with any kind of timestamp, you always have to think about: do I think that the adversary who did this is doing this, is implementing this kind of deceptive tactic? And
Yeah.
I think in this case, like, I'm always naturally skeptical of timestamps, but in this case, I think it's correct. I think
Yeah.
it's accurate.
I would say, not to be too much of a spoiler, but since this ends with a commodity
Yes.
malware family and that the initial access is an RTF document, yeah, we're probably dealing on the lower tier of capabilities. But okay, cool.
All right. So now let's do the opposite and just look at the data. So this is the script. We can look at the script, but it is pretty obfuscated, if I recall correctly. Now, here's a different thing that you can do, though, and I think this is nice. So, just to remember. So, I did not speak about this at all. I should speak about this. When I piped the output of A3X to peek inside this frame, I also gave Refinery the opportunity to attach metadata to each of the binary chunks. So whenever you are within a frame, like when you are between these square brackets, which essentially just means the Refinery units are emitting their output in a serialized format, and whenever you're doing this, you have the ability to work with variables. Like each binary chunk can have a number of variables attached to it. And in this case, the A3X unit has populated a few variables by itself. It has attached a few timestamps that it has extracted from the things that it extracted. It tells you what this is a piece of metadata that is encoded in the AutoIT binary, the source path, like where this came from. Apparently, for lards and backtrace, it came from DXMPP htdocs and then something like this. Yeah, and it also contains a variable called path, which is what, remember when we ran A3X L, like this is the path that the path extractor unit assigns to this chunk. So this will be scripted, AU3, lards, and backtrace. And what you can do if you want to dump this to disk, you can use string formatting syntax in dump. So we can write dump and then squirrely brackets path, and this will dump to disk script.au3 lards and backtrace. And let's try to look at the script. Yeah, it's kind of uncool to read this, and
Yeah, my
I will
eyes just went cross.
yeah, and I will do a thing. So you can look at the strings and you can decrypt some strings because there's string encryption in it. You could, but I'm gonna do a thing that Josh also did, and I think it's the right thing to do. We can just try to be clever. For this, I will again just look at the metadata of what is extracted and look at the size. So backtrace is 0.245 megabytes. This is like the sweet spot for executable size. Then lards is just 57 kilobytes, and the script is definitely just the loader for whatever payload is in backtrace. And I would assume that it's using lards as a helper. There's probably shellcode in there. Let's have a look. So this is the script. This is lards, and this is backtrace. When we pull out lards specifically, it looks pretty interesting. No, lard. Is it not lard? Is it just lard? Was I wrong the entire time? I thought it was lards. For some reason, it will only extract it like so. Why? See? All the bugs that I need to inspect later. But yeah, so it's like a hexadecimal number, but with an asterisk between each digit. So we can get rid of the asterisks by using the REPL unit for replace. You want to replace asterisks with the empty string, and the empty string is the default for the second argument. So after this, you get this, and there is a unit, like you can either remove the first 2 byte and hex decode it, or you can pipe this to a unit called base, which will just try to interpret it like as an integer and convert that integer to the corresponding bytes, which is the same in this case. And this looks like this push EBP, right? This is looks a lot like shellcode. Again, if you do this, it disassembles like really well, amazingly well. Honestly looks like compiled code. It doesn't look like looks like somebody compiled some code and then put it into shellcode. So this supports the assessment we had. Like this is probably a helper. Oh, I know what happened. Ha ha ha. This is terrible. And good to mention this. So when you run A3X, you can specify like a pattern to extract from the file. But refinery units try to be super clever about the arguments that they get. And when you specify script.au3 as the argument, it will try to read the file that exists on disk right now, which is called script.au3, and pass the contents of this file to A3X. Now, in this case, it just fails, but sometimes the path extraction unit can realize what you're trying to do and can tell you invalid path pattern of length insane. If that path exists on disks, these are the file contents. To prevent this, specify s:\path.txt rather than path.txt. So we could have done this, and that should have worked. Yeah. I'm not sure if that explanation made sense. because it has to do with the art. Like, okay, now is as good a time as any to get into how Refinery parses command line arguments. So when you specify, and emit is a good showcase for this. When you just write hello, emit will emit hello. But when you write emit script.au3, which is a file that exists on disk, it will output the contents of that file. Now, sometimes you don't like this. Sometimes you want the actual string script.au3. And so this is the reason why originally I introduced 3 of these magic prefixes. You could type s colon script.au3, which would mean just take the rest of what's coming and interpret it as a string. Another one that I have always had is h, because it's just practical. It does hex decoding. And I have u, which I think outputs it as Unicode, which we can only see when we peek at the actual bytes, because the console will swallow all the 0 bytes. And this I have grown into a pretty complex feature of Refinery, where you can put a lot more things. Like you can have a lot more of these handlers. Like you can put a lot more in front of the colon. In particular, you can put any Refinery unit as a handler in front of something. So you can do hex, which is the same as h from a technical perspective, but in this case, it is using the hex unit to decode this, which is more obvious when you do this, which works, but this will not, because h really wants you to provide one consecutive string of hex digits, but the hex unit is very forgiving. This immediately allows you to do things like passing a base 64 string. I don't know if this decodes. It does. And then immediately turn it into the bytes that correspond to the decoding and stuff like this. This is, I recommend reading the documentation for this. So I'm bringing up the documentation again. At the very beginning of the documentation, there's a few recommendations. So it says, please read about framing syntax. We talked about this. Then it says, please read about the multi-bin syntax. And that's exactly what I talked about. Like these handlers that you can put in front of things. And you can do a bunch of stuff with this. So yeah, please read about this. It can be very helpful. Anyway, for path extraction units, this can cause this terrible confusion where when you write emit rh0.exe and then you do a3x lards, what it will do it will read the contents of lards and pass this as a file name pattern to a3x, and a3x will not find anything that matches the string that is this monstrosity. However, since this is all printable characters, Refinery cannot understand that this is actually not something you want. It can understand when it's like a binary thing. So when you make the same mistake with backtrace, it can realize that this binary junk is almost certainly not the file name pattern that you wanted to provide. So in this case, it warns you. Okay, excursion over. I was about, so again, let's recap. We have 3 files. We think this one is just loading stuff. We think this is just a piece of shellcode that this script uses to decode whatever is in here. So let's just pull out backtrace and look at this for a brief moment. When you stare at this for a bit, it seems an awful lot like there are repeating patterns in there. And whenever something looks like this, I don't know how to describe it any better, but just looks like some of this is repeating V8x, 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 V8x. It just looks to me like an XOR encrypted PE file. And there's a unit in Refinery that is called AutoZOR, which will try a lot of things to automatically XOR decrypt specifically files with lots of 0 bytes, like PE files. And I'm gonna do -VV to show you what it does. And it successfully pulls out the PE. So it says found key via crib PE stub. What it does, among other things, is it tries to hunt for cribs. So it knows a bunch of strings that are known to occur in certain files at certain offsets, and then you can use that as a known plaintext or chosen plaintext attack against multi letter XOR keys. Anyway, this is almost certainly the payload, so we can dump it to disk, and let's have a look. Payload.exe. Okay, I am not Linux well, let's have a peek. Oh, we already did. Anyway, let's have a peek again. So this is a .NET file, and yeah, I mean, let's try our luck. This looks pretty juicy, right? So
yes, let's use FTP.
You can also specify XTP has a magic filter option where the more you filter, the more aggressively it will try to remove things that could be false positives. Yeah, so this one looks good.
Mm-hmm.
I want to do exactly what I would do and open this in dnspy. So this is the one. And what I would now do is I would just search for this string. And I would find it right about here. And I could show you how to pull this out with Refinery. And this will be how to extract the configuration of AgentTesla, is it? I think so. Yeah, it looks like AgentTesla.
Yep.
So there's a unit for, okay, again, .NET. Not exactly what we're looking for. .NET, maybe? Better. And this is the one I want to showcase. This unit can extract data from constant field variables and classes of .NET's executables. Blah, 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 technical bullshit. What? Exception of type. Okay, again, I'm unsure why this should work. Can we pull out strings? No. Okay, it's broken. As I said, this is live, and it's a shame that this doesn't work. Let me try my my Refinery installation over here, which is my local one. Okay, so this is what it's supposed to look like. I don't know why this didn't work, but it's supposed to give you access to constant variables like this, and also allow you to pull out specific ones. So in this case, you could pull out the FTP host, the password, and the user individually. But I do not know why it's not working in this installation, like in this something to investigate when when the stream has ended. Gonna write a regression test and make sure this works.
Mm-hmm.
But yeah, I'm gonna switch over to this because it actually works here. to make this really cool, we could even write like a config extractor where we do like this. Oh, I need to. One more. There you go. Isn't this pretty? For this, I used a unit that I recently renamed because I think it's much better to call it PF, like printf. And it allows you to do some string formatting, some printf style formatting in Refinery. And here we take the path and use a reverse handler called path PB for path base to pull out only like the last part of the path, equal sign, and this stands for the contents of the chunk. And altogether, it formats like this. And you can, and there you have the complete configuration. In one line, it would be, where's the did I lose the? No, I didn't lose it. Okay, so A3X backtrace, AutoZor, DN fields FTP asterisk. And now AutoZor. AutoXOR. There we go. Okay. Ta-da! We have the AgentTesla configuration.
Nice.
All right. Questions, except for why is everything broken in your WSL prompt? I do not know.
Well, Carson asked if that is CipherIt. I think back when we were looking at some of the AutoIT.
Oh, the AutoIT stuff. I do not know. I have not classified it. Is it CipherIt? I didn't even know the name.
Yeah.
You tell me.
I didn't either. I skipped over that and just gave when I did my initial analysis was just did the extraction. So yep, says you can already see it's a PE file. So yeah, there's usually a good indications in that see a binary that you're looking at, that you, I guess the coveted encryption eye, somebody else commented that, yeah, I think you can start to pick out those patterns, and you know, you kind of, you bias it when you're in this sequence of events. You're expecting PE files to be kind of the prominent thing, especially as you get to the later stages. So you kind of look for that pattern in the bytes and the structure, and knowing that, as you mentioned, there's a lot of null bytes. Oddly enough, with the .NET PE files, they tend to shrink the section between the end of the header, the metadata headers, and then the actual .text section. There's fewer null bytes than like a native code or an unmanaged, but still a lot of null bytes in there. Carson's asking, can you share the sample and hash? Yep, absolutely. I've got.
I can even show you. I can even do it with Refinery.
Yeah.
So now
I have to go dig up which video I put it in.
Can I use the chat? Am I in the chat?
I don't know. Are you? You're free to use it if you can.
No, I mean in this interface that I'm. I don't know how to.
Let's see. So I'll put the.
No, I don't know how to use the chat. I am.
Okay. You want to chat with me, or you want to use the chat with everyone else?
Yeah, the public one. I could.
Yeah, you probably don't have permission to do that, and I don't know how to share that. So you can private chat me, yeah, and then I'll pass it on. Yeah, I shared it as well. I pulled the sample from the Malware Bazaar, so easy to get a hold of. Number one rule: sharing samples. Make sure everyone else can grab it.
So. Have hashes.
Yeah. Okay. We're getting okay. So it's been a little over an hour, so we're probably going to wrap up here soon. If you have questions, keep them coming in. Happy to stay on as long though as questions here. Let's see. We do have another question here. Do you save these config extractors into Python scripts? I saw in the docs that it's possible, but the syntax was a bit different.
So what I usually do, I said this on last stream as well. I just copy paste my entire pipeline and put it into a text file, essentially. Refinery has very extensive support for using it in code, and the in code support mimics the command line usage quite a bit. So we can try to do this if you like for this one, for example. Let's do like decode.py. So it needs to run in like a. I'm doing this completely live. I don't know if this will work. System cannot find the files. Oh, I may probably not execute anything in here. Oh no, BR. Maybe sorry. Maybe this was the problem. So I have to find. Okay, this works. Right. Sorry, I have to make sure that I am in an environment that has Refinery installed. But when you and I solve this by having like a magic shebang for Refinery. Unfortunately, the environments I use at work and at home are different, so I keep confusing them all the time, and I should probably change that. You could write a class that inherits from unit, and then all you have to do is. I'm not sure if this is what you're asking, by the way. Please interrupt me if I'm not doing at all what you wanted. But you can do. You can do this, I think. I mean, of course, you have to be. It doesn't work exactly like a command line. In this case, we don't have to do this. And then this is not valid Python, so we do this. And I'm not actually sure. Do I have to do this? I don't know. Let's try. No. Oh, yeah, sorry. This is also not valid Python at all. Like, not even a little bit. Not quite. Is with int literal. I do not know what it wants from me. Cannot import AutoZor from Refinery. That is sort of odd. Should be able to. Oh, this is, I know what's happening. So this is probably a very old environment. Let's try fixing this. Give me a second. I'm not sure if this will work. Yeah, okay. So I had to make sure that I am running in a virtual environment, like that I'm running in a Python interpreter that has the most recent version of Refinery so that AutoZor exists. This one is ancient because I haven't updated it in many moons and it didn't even know AutoZor. But now, in principle, you could do this. You could write it like this, and then just running PyDecode behaves exactly as if you had done the whole shebang. You can even like peek the individual outputs, and it will even have retained all the meta variables and stuff. Mm-hmm. So this is how you can use Refinery units in code. It's it's in the documentation. This is not your only reference. There's there's documentation about how to do this. I'm not sure if this is what you meant, though. It's kind of cool to show off, so I wanted to do it, but I'm not sure if this is exactly what you wanted.
Sure. Yeah. They also asked, is there a way to write custom units?
Yes, this is it.
This
is a custom unit that is basically just a shortcut, but of course you can just return data plus hello world, and then if I do emit Jesko, or now let's Josh, and I pipe it to Pi, it will say Josh hello world, because that's what you told it to do. So yeah, you can write custom units, pretty much like this. Even though I messed it up, I recommend having like a shebang shortcut to the Python environment where your most recent refinery is in, and then you can just like when you want a script to be a custom unit, you can like put the path to your virtual environment up here. To be honest, I don't know how this works in Linux. In Windows, you have to configure some ini file somewhere to tell it that whenever the shebang is BR, please use the virtual environment over here. I don't like, probably on Linux, the way to do this is an alias, where you have to alias to a specific executable in a virtual environment. But as I said, I'm Windows native, so this would be my choice.
Okay. Yeah, cool. All right. I know there's a bit of a lag with the streaming software and the platforms, so hopefully that's not too tough to navigate for everyone. But we are, I think, getting close to the end here. Is there any? I mean, unless there's anything else you wanted to discuss or to demo.
No, I'm pretty happy. Like this is exact. Like it took up exactly as much time as I thought it would. I didn't need my backup content. I got through to the C2 server, and I got to do it all with Refinery essentially. So.
Yeah. Oh yeah, excellent. All with Refinery. That's really cool. Yeah. If you go, look at the other playlists, the videos. I guess I didn't use Refinery. I don't believe I used Refinery in any of those. But I tend to gravitate towards the things that I've always known, and there's always that inertia of trying to work new tools into your workflow.
And let me just admit, it is kind of cryptic, right? I mean, even I know that it's like I wrote this for myself, and it has this. I think we spoke about this on the last stream. It has this Radari 2 taste where everything. Like every command is almost like Huffman encoded to be super short and hard to remember. I try to support it with documentation and like this binref tool, but I can completely understand when it's like when people think it's cryptic, because it is. So nobody should feel bad if they don't use it. Just if you think it's useful, give it a try. So.
Yeah, I think I ran into an issue piping, like using just like a PowerShell prompt, piping binary data. And then I came across a GitHub issue, and I started going down this rabbit hole. And I will admit, when I'm usually, I'm the kind of person that, and like a lot of folks, there's 30 hours in a day. So I'm always I'm always a little bit behind. And so when I finally squeeze in time to make a video and I don't anticipate a troubleshooting rabbit hole, I'm like, okay, I'm just going to scrub that. I'm going to go with the thing that I know how to do it in. And the purpose of that whole series of videos anyways was just like RTF documents, and I had this little Yara rule that I created to show how you identify the entry point, and then use that and Yara to get the offset to feed it into a shellcode thing. Much better approach here, but
well, I mean, it depends. I thought it was a really your focus is also to teach people things, and I think teaching about Yara is really important. It's one of the most important tools. I didn't address that at all here because the focus was Refinery, but So if you haven't watched the RTF series that Josh did, do watch it, because it's great for other reasons. It's a good introduction. He addresses, he explains many of the things that just happened in a much better way with much more detail.
I think about that. You were talking about verbosity modes, and I do usually, when I'm putting video content together, I'm a tech VV, just because I want everyone to understand all that underpinning stuff and the stuff behind it. But okay, well, I don't see any other questions. If anyone has anything, of course, this will now be there on YouTube for perpetuity until YouTube takes it down or eventually says, hey, we've run out of storage. I don't know when that would be. I would imagine, I think of these videos in a way as like they'll be there forever, but I suppose at some point YouTube
nothing is forever.
Finally decide to take them down. So anyways, comments are open. Please feel free to leave comments there. I'll monitor and make sure to answer appropriately. let's see. I think we are probably at the end of time. So thank
Yeah.
you again
Thank
so
you.
much for coming on, showing off the tool. What an amazing tool. Really glad that you made this public because I mean, I'm sure that was a
Me too.
massive leap from, having something like this, especially something as robust as this that you're just using for yourself, and there's really no pressure.
Oh, have I not spoke about this before? Let me. Can I do 2 minutes of a nice anecdote?
Absolutely.
Of course, it wasn't a cool, robust tool in the beginning. It
Mhm.
was a directory with like 5 Python scripts. One was called hex.py, the other was called b64.py, and then I think I had one. I had one for gzip unpacking because I'm on Windows, and I used to not like Linux folk would laugh at that, but I was like, I don't have a command line gzip, and I wanted to do essentially. I just wanted to be able to do. I wanted to have feature parity with a Linux shell. And then it was a directory with a few ragged Python scripts. And I asked like my manager at the time, can I make this open source? Is it okay for? And he looked at it and says, of course. And so I got permission to make this open source when it was not like the thing it is today. So, and I think that was so for anybody out there who is considering making something open source that they use both privately and at work, I would recommend try to do it early when it is not big, because when you are working at a company and you have written a big piece of software, I suppose it will be more difficult to make it open source. But when it already is open source, there's no way of going back. Just my.
Yeah.
And to be perfectly clear, I don't know how things would have turned out if I have absolutely no idea. But when I made it open source, it wasn't very impressive. So,
Okay. Well,
my opinion.
It certainly is now, and I would agree. My experience, it definitely smaller the better, and once you've gone to open source, it's harder to pull that back. So glad it found its way out there. One suggestion here from
Yes.
YouTube is next time Rust base binref.
Oh man, you always open the can of worms.
Yeah.
If
So
if only Rust had the ecosystem that Python does, is all I'm going to say about this. I would.
all right.
All right.
Okay. All right. Well, thanks everyone. Thanks for joining. It was great to have you all here. Hope you enjoyed the stream. Jesko, thank you again.
I certainly
Always
did.
awesome.
Thank you.
I'm sure we will be in touch, and I will be asking you to come back sometime in the fall.
Nice.
But until then, enjoy your summer, and I guess that's it. So live end the stream here, and see everyone on the next one. Remember, July 10th is the scheduled Kyle Cucci, author of Evasive Malware, and I think our focus is going to be Go malware. So go.